So this is my first attempt to create a video for you all, and if it doesn't go well, I apologize. It's raining outside, so if you hear some pitter-patter of raindrops, that's what that is. My cat is currently sniffing around my iPad, so if you hear some odd breathing, that's what that is. And here we go. Let's see how this goes. So this is from the section in the first section of Chapter 1 in your book about the graphs for categorical variables. There are actually a few different things that we're going to talk about in this section, but overall, the most important point is the graphs. So first things first, in terminology. We've got three basic terms that we need to define here. The first is being individuals. When you're collecting data, the individuals are the people generally, or maybe the events that you're collecting data on. So today in class you looked at some data that came from various students in our school. Those students were the individuals that data came from. Then there's this term variable, a lot like the variable that you would have referred to in an algebra class. The variable is just some defining characteristic of those individuals that you're going to measure. So some of the things that we looked at in class today were people's ages, people's heights, and then people's eye colors. Those were three different variables that we looked at. And then the last term that you need to be familiar with is distribution. Distribution is just the word that we use to describe all of the different values, that a variable could take on. So for instance, if the variable we're considering is eye color, its distribution would be any of the possible eye colors. So blue, brown, green, gray, something like that. Now the next thing we need to talk about are the two basic different types of variables you can have. The first type is a categorical variable, and we're going to learn about how to graph or create graphs for categorical variables later in this lesson. And the other type of variable is quantitative. And if you look at the roots of those words, you can figure out what they're describing. So a categorical variable is is a variable that falls into some sort of category. So for instance, eye color again, like we looked at today. Eye color falls into one of several various categories: blue eyes, brown eyes, etc. A quantitative variable is one that is a quantity. So if there's some numerical value assigned to that variable, then it's generally a quantitative variable. So again, we're going to talk a little bit about how to create graphs for categorical variables in this lesson, and then in following lessons we'll talk about how to create graphs to describe quantitative variables. So here's some sample survey data. I got it out of one of the various stats textbooks that I have. So let's take a look. We've got some information about gender, handedness, height, the amount of time spent on homework, favorite music, and pocket change. So let's categorize these various variables in terms of whether they're categorical or quantitative. Remember, categorical means that the variable can only fall into certain categories. It's not a particular value. So for this example, we have gender being a categorical variable. Handedness would be a categorical variable, and the favorite type of music would be the other one. And then remember that a quantitative variable is a value, or a variable that can take a certain value. So height would be one, homework time would be another, and the amount of pocket change that you have is a third. And then just to go over what an individual is one more time. It looks like there are 1, 2, 3, 4, 5, 6, 7 rows of this data, and each row corresponds to the data for one particular person. So that means that there are 7 individuals whose data is represented here. Well, now that you've got your data, let's say that you want to create some sort of visual display to represent that data so that you can easily understand how the values are distributed. That also can make it easier to communicate the distribution of your data to someone else. Just looking at a table of values is not always particularly helpful, especially if you have many, many individuals' data summarized. So we have two different types of graphs for categorical variables that we're going to look at. One type is a pie chart, and I'm sure you've seen pie charts many, many times. And then the other type of graph for a categorical variable is a bar graph, also a type of graph that you're probably familiar with. Those are really the two basic types of graphs for categorical variables that you need to be familiar with. The good news is that pie charts are not something that you'll have to draw by hand. You cannot create a pie chart on your calculator, and creating them by hand is a bit of a pain, because if you're going to do it, or be accurate about it, I guess I should say, you would need a compass and a protractor so you can measure angles and all that. And the College Board, the people who put the AP test together, that's not something that they're concerned with you being able to do. So I'm just going to create a really rough sketch of a pie chart here just so you get an idea. I had great plans to create a nice a nice visual of this in one of my applications that I've got on my iPad, and that just never seemed to work out. So I apologize, but you're going to have to deal with my somewhat sloppy sketch. So let's say that we want to create a pie chart for the data on handedness. So that's the same data that was just shown to you a couple slides ago. So on that data, there were 2 people who were left-handed, and there were 5 people who were right-handed, and there were a total of 7 people. So 2/7 of the people are left-handed, 5/7 are right-handed. So if you do that out in percentages, approximately 28.6% are left-handed, 71.4% are right-handed. So as I'm sure you're familiar with, a pie chart is generally just shown as a graph of a circle, and then however many categories you have, the area of the circle that's assigned to that category is proportional to the percentage of that variable that that category takes up. So for instance, since here, this is a pretty simple example, we only have 2 categories that we're dealing with. Since the people who are left-handed only take up 28.6% of the population, they only get 28.6% of the circle. So roughly something like that. And then the people who are right-handed, since there are only 2 categories, they get everything else. So here are the left-handed people, and here are the people with right hands, or who are right-handed. I hope everybody has a right hand. And that's really all there is to it, to a pie chart. They're a little bit more interesting if you have, 3 or more categorical variables that you are comparing, but for our purposes, it's a pretty simple example. Okay, so the next type of next type of graph that we are interested in is a bar graph. And we are going to look at the musical preferences for this one. So there are 4 different categories for music preferences that were shown in that data. If we want to create a bar graph from this data, we have 2 options. We can either choose to orient our bar graph horizontally or vertically. I'm going to create mine horizontally simply because I don't have a whole lot of space on this slide. So if we're going to do that, I'm going to draw a vertical axis, and then I'm going to label all of my various musical preferences. There was an alternative preference, there was country, there was hip-hop, and there was rock. Now, because this is a relatively small data set, there are only 7 individuals in here, this isn't going to be a particularly interesting bar graph, but again, it'll still serve our purposes. The distribution for these various categories were that 2 people liked alternative, 1 person liked country, 2 people liked hip hop, and 2 people liked rock. So on our horizontal axis, I'm going to label the values. We've either got 1 or 2. Notice that I'm making those relatively evenly spaced. And then for each of the categories, you just draw a bar that is equal in length to however many individuals fall into that category. So for alternative, again, we had 2. So I'm going to draw a bar of length 2 for alternative. Oh, let's get fancy and do some different colors. For country, only one person chose country. Can't believe that many people went with it. Let's see, for hip-hop, we've got another 2. And finally for rock, again, we've got 2. And there you go. A little bit sloppy, but you get the idea. Again, the bars in a bar graph, the length just represents the number of individuals who fall into the various categories. So we've gone over our 2 different types of graphs that you can create using a categorical variable. Notice that we did not talk at all about creating a graph for any of the quantitative variables. Again, that's something that we'll get to in subsequent lessons. The very last thing that I want to talk about real quick is this idea of going from data analysis, which is essentially what we've been doing. We've been taking data, looking at it, and in this case just creating a graph from it. There's lots of different ways you can analyze data. So we want to go from data analysis to what's called inference. And this is something that we are going to be talking about all throughout this year. We'll especially be focusing on inference techniques towards the end of the year. And what this means is that if you're doing inference, you're taking data from a sample of people, because a lot of times it's not practical to take a sample or take data from a population. So what does that mean? Well, a sample is just what it sounds like. It is a small select portion of your entire population. So, for instance, the data that you looked at in class today, that's data that I collected from students in my classes. So that was a sample of all of the students in the St. Francis community, which would be the population. So the population is everybody. The sample is a subset of the population. And what statistics does is it gives you the ability to take data from a sample, and then if you have done things correctly, you may be able to make inferences, meaning making certain statements based on your data from the sample about your population in general. So this is something that we are going to be talking about quite a bit throughout the rest of the year.